exponent n, and our y exponent is going to start at 0. And we're always going to start our first coefficient as n combination 0. The next coefficient in the row is going to be n combination 1, and then n combination 3, n combination 4, and so on until we get to n combination n. So depending on what your exponent is, right, that's going to be your n value. So in general, our binomial theorem is n combination 0, x to the n, y to the 0, plus n combination 1 is the coefficient of my next term, x to the power of, well, I'm going to take 1 away from my exponent, and I'm going to add 1 to my y value. So my x exponents are decreasing by 1, my y's are increasing. N combination 2, x to the n minus 2, y squared, and so on until we eventually get to n combination n minus 2, which is the end point here, x squared, right, we're nearing the end, y to the n minus 2, n combination of n minus 1, x to the 1, y to the n minus 1, and then finally n combination n, x to the 0, y to the 0. So this is just the general binomial theorem. If it's confusing you, you'll see how it unfolds when we do an example. All right, so for example, if we wanted to expand the following binomial, 2a minus 3b to the using the binomial theorem. So before I do that, I am going to expand just an x plus y to the power 4, where x really relates to our 2a and our y really relates to our negative 3b. So if I expand this, in order to expand this, without having to write out our Pascal's triangle, I'm going to start at 4 combination 0. That's my first coefficient. And then my power on x is going to be n, which is x to the, and then this is going to be y to the 0, which is just 1. So there's no y value on our first term. And then I'm going to go to my next term. My next term is going to be 4 combination 1, x to the power of 3, y. My next term is x squared, y squared. So as you can see, my exponents on x are decreasing by 1, my exponents on y are increasing by 1. And I'm just continuing the pattern with my combination. So 0, 1, 2, my next one would be 4 combination 3, x, plus finally 4 combination 4, the x is gone, and we just have y to the 4th. All right, so this would be the expansion of x plus y, but now we want to relate x to a 2a and y to a negative 3b. So now we're actually going to substitute in those values to get our final expansion. So at the same time, we're going to evaluate these combination values. So add on your calculator, 4 combination 1, or 0, sorry, is 1. So this is 1. I'm now going to replace my x value with its actual value, which is 2a. And I'm going to take that to the power of 4. Plus 4 combination 1, well, if we evaluate that on our calculators, if you don't know it, it should be 4. So this would be 4 times 2a to the power of 3 times a negative 3b, which is our y value. Plus 4 combination 2, if we evaluated that, ends up to be a 6, a squared, negative 3b squared. Plus 4 combination 3 ends up to be 4 times 2a times negative 3b to the power of 3, plus 4 combination 1 is, or sorry, 4 combination 4 is 1 times a negative 4. So now we just need to clean this up by actually applying these exponent values to each of our terms. So 2a to the power of 4 would simplify to a 16a to the 4th. I got a 2 to the power of 4 is 16, a to the 4th. Plus, I'm going to evaluate each of these. So 2 cubed gives me 8a cubed times a negative 3b, plus 6, this would be 4a squared, times a, well, if I square a negative, this changes to a positive, just 9b squared, plus 4 times 2a, this is going to be a negative 27b cubed, and then finally negative 3 to the power of 4 is going to end up to be a positive 81b to the 4th. And then finally, we're going to clean this up. So our final expansion would be 16a to the fourth. I would multiply 4 times 8 times a negative 3. So this is going to be a minus 4 times 8 times a negative 3 is a 96a cubed b, plus 6 times 4 times 9 is 216a squared b squared, times, or sorry, minus 4 times 2 times a negative 27 is negative 216 ab cubed plus 81b to the fourth. So there is our expansion. Okay, so how do you, I would always suggest that you expand the x plus y to whatever power you have first. That was, and then you take whatever your x value relates to and your y value relates to and substitute it in. All right, and that is the end for day